Hi, in this video, I will show you how to decrypt an LWE ciphertext. And we're going to be using Maple because this is the go-to language in my class and also in a lot of mathematical classes. So here's the question. You are given a ciphertext and the secret key, and you are tasked to decrypt C. So we're only here following the recipe, and I'm going to just recap very quickly, how this is done from a theoretical standpoint, and then I'm just gonna pop a Maple session, and I'm gonna solve for this particular instance. So remember, you have a matrix A, okay, that is a matrix over ZQ for some Q, and then it has M rows and N columns, okay? And so this is public. And then the private S, is multiply by A. And then there is an error coming from a certain distribution that is added, okay, to make this hard to recover S. And that gives you the B, okay? Now, you noticed probably that in the ciphertext, I have an A sub X and a B sub X, okay? So here, I'm only recapping the formulas, right? In a separate video, I explain exactly how, where this all comes from. But this AX and BX, once you're given the public key, so the public key, which is made of A and B, okay? And so if you want to encrypt a message, okay, so you do not have the secret key, what you do is you select a subset of the rows of A, and you're gonna just add them up, okay, and same thing for B, okay. So what happens here is that, let's say X is a vector, with zeros and ones and ZQ to the M, okay, and then you multiply that by A, my bad. So if you multiply that by B, what do you get? Okay, so if you multiply this by B, you will get X times A times S plus X times E, and that's equal X times B, okay? So here, if I want to call that, I can call that A sub X, okay? A sub X. This is an E sub X that I assume if E is small, then I can assume that it's a small error, okay? It stays small if the subset of columns, a subset of rows that I choose encoded in X is a small subset, I can hope that E is going to stay small, and that I'm going to call B sub X, okay? All right. And so here, what I want is to be able to encrypt a message. So I call it that message mu, and typically mu here is just a 0 or a 1. And then the encryption is going to be given by, so A sub X, okay, I have to give it away so that the person who decrypts is going to be able to recover A sub X times S. And then here as a second coordinate, I'm going to have Bx plus mu, so which is a 0, 1, times the rounding of Q over 2, okay? And all of that, of course, it's all mod Q. Maybe I should write it down just to be on the safe side. All right. So what happened here? I have on B, so on the second coordinate, what I have is so AX times S plus an error plus the message. Okay, so really, if you have the message, if you have the the secret key, the secret key S, you will be able to retrieve mu times Q over 2 plus an error. So I'm going to scroll up a little bit here. So now assuming you're here, okay, you're at this point and then you have S. So what do? So decryption, because this is really what we're trying to do in this particular exercise. So the decryption, you first calculate AX times S, all right? And then the second coordinate of this ciphertext, it's precisely AX times S plus mu times Q over 2 plus some error that I'll never really know what it is in advance, right? But the thing is, if I subtract the second coordinate of my ciphertext, so if I do this minus AX times S, then of course this and this cancel out. And what am I left with? I'm left with mu, my message, Q over 2 plus EX. And that is approximately equal to mu times Q over 2. It won't be exactly, okay? In fact, it depends on the error. The error you're not in control of as the person who decrypts. However, what you know is it will be small enough. And what people do, of course, is we choose it to be less than Q over 4. Okay, so that if if mu Q over 2 plus the error is close to 0, modulo a factor Q over 4, so it's at distance at most Q over 4 of 0, then we'll declare it to be 0. And otherwise, it will be declared to, mu will be set to be 1. So let's just do this with Maple. So here I've already typed everything that is needed. And that's because otherwise it's going to be really painful for you guys to see me type. So you need to first load the linear algebra package. Okay, that was not really interesting, so we're doing it very quickly. So the linear algebra package will load everything you need from matrices. Then you have here your S and your AX and your BX as given in the questions. Okay, so I need to type this. Okay, and then here's my, I called it a buffer, okay, which is just I multiply AX by S, okay, and this is AX multiplied by X, so the same thing that I said we should do first step to the decryption, and then you take this second coordinate here, and you subtract it by the buffer, okay? So you're effectively canceling the AX times S component. All right, so let's do this. And here I get 52. And then the question is, after that, so when I look at 52, knowing that my Q was 101, okay, the question is, am I looking at the decryption of 1 or the decryption of 0, okay? And I need to do this rounding phase. So let me go back real quick to my drawing board. Here I have the following. I have that mu times Q over 2 plus some error bounded by Q over 4. This is 52, okay? Now Q over 2 is 50, okay? Because Q is 101, okay? So 50 or 51, depending on how you round. Okay, let's say it's 50 because who cares? And then Q over 4 is gonna be about 25, okay? So clearly, if I draw a line, okay, and I say, okay, I have the possibility of having a 0 or a 1, okay? And then if it's a 1, then I'm getting Q over 2, okay? And then I'm gonna have, so anywhere between Q over 4 and Q over 2 is considered to be a 1. And then you can also have the error acting positively, right? So you can add a Q over 4, so everywhere between 3Q over 4, oops, sorry, my bad. So everywhere between 3Q over 4 and Q over 2 is also considered to be a 1, okay? So here is everywhere where I would declare this to be a 1, okay? Mu equals 1. Okay, now in our case, because we're so close to 50, this pretty clearly that the message was 1, and that's what we're going to say as the decryption. Now, I feel compelled to tell you, though, that there is a little trick that if you reduce things mod 101, which you probably want to do when you perform your calculations, then, you know, here is, I'm going to put in green just for the argument here. So clearly, between 0 and q over 4, that was a mu equals 0. Now, you also have everything here, right? When the error is negative, right? This is considered to be also a 0. But when you reduce mod 101, what's going to happen is it's going to move everything between 0 and 100, okay? And so what happens is if you had, say, -1, which is also very close to 0, surely within distance q over 4 of 0, okay? However, it's going to move things between 3 times q over 4 and q. Let me write down here q. And so everything here, you got to be really careful here, everything here is also a mu equals 0 if you've reduced modulo 101. So this is the only subtlety. I mean, this is really not that much, but bear in mind when mu equals 0, you might find yourself looking at something close to q as the result of the decryption of mu equals 0. All right, so now you know how to decrypt an LWE ciphertext using Maple. Thank you for watching.